Alright, we're taking a little bit of time to get online here, and this is Telescope Room. We've got Christina out there assisting us today. We may have an audio problem. I need to check something. So I'm going to mute my microphone for just a second, and you can watch us here while we're setting up the telescopes. Okay, we'll do one more audio check. Just 1, 2, 3, 4. We'll try this again. Maybe this one won't have the echo this time. We're just trying to get online here. We're getting an echo in the audio, so bear with us for a second. Okay, Christina, can you go ahead and see if you can turn up the integration on that a little bit so we can see a little bit more of the spiral arms of that galaxy? This is M109. So we'll let Christina adjust the picture here, see if we can get a little bit more of a spiral there. I'm seeing a little better now. And
the barn spiral, or one of them.
Yep. Yes, it is. Let's turn that knob up a little bit farther. Or did you just?
It just, yeah.
Just up. Now I can see definitely a spiral there. Let's see how it gets here. So we're just getting things set up, and we'll be right with you. Oh well, we'll go ahead and okay, so this is M109. It's a let's go ahead and center that up a little bit. Okay, I'm going to move that over just a little bit so it's in the middle of the screen. I'm thinking maybe it's a little bit out of focus. The right-hand edge looks a little out of focus to me. Did that not move? There we go. Okay, I'm going to go out there and see if I can get this to focus up a little bit better. So I'll be right back. Okay, that got worse, and now hopefully it's going to get better on this next sample. Oops. Okay. A little bit better. I turned it a little bit. If you go just counterclockwise, like an eighth of a turn more, maybe on the fine one. Take the fine knob and go back about an eighth of a turn left counterclockwise. And we'll see how that works. And then we'll get started here on doing our observing list. Okay, we're waiting for this time exposure to do one more click here. I'm going to run with this. That galaxy's looking pretty good there. Okay. You guys ready to start out there? Okay, so we have Christina and a guest out there tonight, and they'll be helping adjust things on the telescope. This is M109. It's a small magnitude 9.8 barred spiral galaxy in the constellation Ursa Major. It's about about 1/3 of all galaxies known are the barred spiral category, as is the Milky Way. Look for the prominent central bar with the spiral arm from the end. On dark nights like tonight, we can try to trace the irregular and brighter arcs within the arms. It's you can kind of see there's a bar going up and down a little bit diagonally, and then there's a swirl and another swirl, and then some spikes coming off of those. So that's M109, a barred spiral, and Ursa Major. So, Christina, you want to go ahead and go over to the control panel and hit M13 for us? Okay. So as the scope moves around to the other side of the sky, not much to look at, but we can watch you guys watch the telescope. Okay, so M13 is almost straight up according to that, huh? Yep, it's pretty close to the meridian. So, all right. Well, it's still the barred spiral. Our camera hasn't updated yet.
I used to keep laser pointers. Oh, this one. Oh, I don't think it works. It has no batteries. That's no.
Do you need a laser? You got it.
I got it.
What are these streaks?
Oh,
Those are like satellites or stars.
Okay. Our guest was just asking what the streaks are, and that was because the telescope was moving while it was doing a time exposure. So not quite centered up here. You want me to center it up? Yeah, I'll go ahead and move it over. We did a meridian flip, and so sometimes that makes it not be exactly centered up. So this is in Hercules. We're just off the left side of your screen there. We're adjusting the telescope. You should see it move over a little bit and up. There it is. Beautiful. Can't wait till we get an actual HD camera. This is standard def, so we're working on upgrading the camera soon. So M13 is a beautiful globular cluster. It's 5.8 magnitude in the constellation Hercules. It was discovered by Edmund Halley in 1714. M13 is one of the most prominent globulars in the northern hemisphere. In 1974, the 305-meter radio telescope at Arecibo, Puerto Rico, sent one of the first radio messages addressed to possible extraterrestrial intelligence to this area. We now know that the primitive low metallicity, is that how you say that?
Yeah. See, it doesn't roll off the
Yes,
tongue.
I know, it doesn't come off either. The primitive low metallicity composition of these early population 2 stars make it highly unlikely that life as we know it could have arisen there. So metallicity is the other elements. When we talk
everything
about
other than almost like hydrogen
and helium, yeah, astronomers tend to consider everything else a metal.
So because those are the older stars, we can see by their composition.
So well, these are actually old stars.
Yeah.
But they were not formed like our star was formed out of dust and gases after supernovas.
Exactly.
So the supernovae left other heavy elements. So our star has some calcium and iron and all kinds of stuff. Yeah. So these stars are more pure, I guess. It doesn't have the stuff of life out there, I guess. And they're kind of orbiting the perimeter of our galaxy. But M13 is a really nice globular cluster. I've it's hard to count, but I've seen anywhere from 300,000 to 500,000 stars, all gravitationally bound. One of my favorite summertime objects. It's just gorgeous if you look at it through the like 7 over there in the background. The If you put a nice eyepiece in there, like a 17 millimeter eyepiece, it looks like a diamond brooch. so, um, so that's M13. Next, let's go ahead and go over to M92, and I guess I can go ahead and bring that up for you. So we'll go ahead and move the scope. M92 is also in Hercules. It won't take too long to get there. Have to wait for the camera to update here. We're doing some fairly long exposures because it's a nice dark moonless night. Okay, this is M92. Let's let the camera have a little bit more time here. I don't know why we're seeing two globulars other than maybe it's a double exposure from when it was moving. Christina, may I see the iPad? There we go. I'm just wondering why it looks like, well, it's still moving, I guess, is what the problem is. So the one nice thing about dark skies is we get some really nice pictures. The hard part about that is it takes forever for the camera to update. And I don't know why it didn't center that better. That's not exactly centered, is it? I think I'm going to have to go. Let's go ahead and move this to the right 1, 2, 3, 4 seconds and up just a little bit. Okay, let's wait for the camera on this one. I could put you on camera and you could do a little dance out there or something. Here we go.
There it is.
Okay, well, it's coming in. I think I moved a little bit too far.
See, I changed my shirt, Charlie. You say to the moon.
Oh.
I put Pluto.
Pluto.
Why?
Show us that, and because of tonight. Go ahead and,
Can you see it?
oh yes.
Can you see it?
Pluto.
So we got
New Horizons star? Is it New Horizons?
so New Horizons has done the Pluto. So yeah, we made a mission to Pluto and we successfully flew by today. And for that, we ought to bring up Pluto and show you what Pluto looks like in our telescope. It's out tonight.
It is.
It's in Sagittarius. So I'm going to bring this, I want to center this up a little bit more, so I'm going to bring it down and a little bit to the left. We're going to have to wait again. I'm sorry, folks. The thing about astronomy is you can't do it fast. So even when you look through the telescope with your own eyes, you should wait a while, let your eye get used to what you're seeing, because you'll see more and more over a period of about 30 seconds. So after this gets centered up here, so as you can see, what happens is the camera is taking long exposures, and it's actually a video camera, but it does, I think we're doing about 20. exposure. So it's when I move it, you're seeing the streaks of, we move the camera and then, or the telescope. So we'll edit this down, make it shorter. We'll get rid of this part of it. But you're watching it live, so this is the way it is at the observatory, live. A couple of people watching us. We should actually post to Facebook and tell people we're on, huh? See if our concurrent users come up a little bit. Okay, so this is M92. It's still down a little bit too low. Okay. Went too far, didn't I? Down. We'll have a bunch of them on the screen here for a second. Okay, it's almost settled in now. Okay, M92, a globular cluster in Hercules. M92 is a 6th magnitude, just a little bit dimmer than M13, globular cluster in the constellation Hercules. M92 was discovered by Johann Bode in 1777. This excellent object has a true diameter of 109 light years and a mass of 330,000 suns. Compare this globular cluster to nearby M13. It's a little bit smaller, looks like, but both of them are excellent examples of globular clusters. So all that and took a while, and now we're ready to go to the next object. Let's just absorb this for just a minute here. So do you notice anything different about this globular cluster? It's hard to tell on the video monitor. I think there's a little more color in M13 though. A little more densely packed. This has a hard core, but it's a little bit opener. Okay. Okay, go ahead and select M92 on the, oh, that's what we're on, the M4. Oh, hold on a second. Let's center this up first. Okay. You want to select M4 on the controller there? And then we'll get off of M92. So M4 is, again, on the other side of the sky, isn't it? Okay. Let's let that settle in a little bit. Oh, you know what? We're gonna have to turn off the lights. Are you hitting the wall a little bit? Um, looks like. Christina, can you tell if that telescope's actually pointed at the wall just a little bit or something? I think the red. Yeah, okay, I think the red is from the wall. Go ahead and turn off the rope lights. That'll probably help. And I'll get this centered up here. 1, 2, 3, 4. Okay, now it's a little darker out there. In fact, I'm going to turn off my red lights here in the office. Get it darker out there because what I think we're seeing is the red from the wall getting into the picture, because I think we have just a slight touching the wall here. So another globular cluster, less tightly packed here, obviously. This area of the sky does have a lot of color, but I just knew that was way too much. I want to go left just a little bit. You know, it's funny. I can't even see you out there now. But in the camera, we can see you perfectly because it's got the infrared. So I can still see your Pluto shirt. Can't quite see the laser. Oh, maybe a little bit. Yeah, not really. The lasers, yeah, infrared and green are not the same. Maybe if I put the camera back to color. Okay, so this is about to settle down here. Went a little too far to the left. I'm going to buy that. Okay, M4. What a difference turning off the lights makes, huh? M4 is a globular cluster in the constellation Scorpius. It's located in the celestial map near the red supergiant Antares. This cluster is approximately 70 light years in diameter. Look for a bright bar across the ball of the cluster, leading some to imagine a cat's eye in the sky. At only 6,800 light years away, this is one of the nearest globular clusters to Earth, and it would be much brighter but for the heavy interleaving gas and dust. So there's a lot of gas and dust in that direction because we're looking toward the central plane of our galaxy. So M4, which is near Antares, that might be fun just to go over to Antares. Cancel. So we do a little excursion over to Antares. It's right. Antares Nebula. Scope moving. Okay, it didn't move very far. take the title out because we're moving away from there. Oops. Okay, there's Antares. Come streaking in there. We're actually looking at the Antares Nebula. It's a big, it's way bigger than the camera though. If we had a wide field camera turned on, you'd be able to see some color glow. So some of that orangish glow around there is real. The star is obviously very bright orange. That curvy streak is from the telescope moving. We're still seeing some of the cluster behind it. So let's let the camera update one more time. There you go. That's Antares. Okay, so let's go ahead and head over to M15. So where's that scope headed? It's headed back on the other side of the sky, isn't it?
Yeah, flipping meridian.
Well, if we're looking at things, it's probably south also, and we're kind of just giving it a workout. Just that time of the night. So we're going over to Serpens, I believe. Yeah, Serpens County. Get the title. M16. Can you put that up for me out there? A little too far, huh? Okay. We got two Eagle Nebulas. Two Eagle Nebulae. Starting to get into some of the fun summertime things. How'd you do that?
I know. Did I zoom in?
Somehow, I mean, normally that scope moves linearly up, down, left, right. How you got the curve? You must have just perfectly hit a left and a down or something, or she's making Star Trail artwork. And there's Christina and our guest there. Aha, there, that's getting a little bit better. Yeah, let's move to the left and up a little bit, because I can't see the whole eagle. So did you move it yet? Okay, so we're just waiting. Ah, a little far, huh? So about half that distance back in both areas. So we'll, at the end of our list, we'll remind me and we'll go to Pluto.
A little bit more to the right.
No, I guess I can deal with that. That looks pretty good. I still see some streaking, so oops. There's a lot of streaking now. We'll give it a little bit of time now. Okay. That's looking pretty good, huh? Are we missing anything behind the banner there? No, not really. Oh, we're still moving, aren't we? I think this is going to be it. You won't have to move it anymore. So do you see the eagle in that? He's kind of flying down, isn't he? Oh, those those are supposed to be his talons. So I think his head is actually down, and his wings are to the sides, and his talons, and then his tail is up where the cluster of stars is his tail. Because if you look at that through the 17-inch, you won't see all the other clouds around it, and it'll look a little bit more like he's got a beak at one end and then the fantail at the other end. So anyway, the M16 is an open star cluster with an associated emission nebula in the constellation Serpens-Caudia, which is just above Sagittarius' teapot. While the cluster is designated M16, the better-known emission nebula is identified as IC 4703. We generally just call it M16, the Eagle Nebula, though. The nebulosity extends over 300 light years from edge to edge and is a hotbed of ongoing stellar formation. The most interesting features of M16 are the pillars of creation made famous by the Hubble Space Telescope images. These dark columns are composed of molecular hydrogen and dust being blown away by intense ultraviolet photons emitted by bright new stars. And if you look at that, you can see a shock wave at the head of each pillar. There's just a lot of detail in there, even with this camera that we've got. If you look at the three pillars in there, right in the middle. There's actually little bumps on there, which are where the protostars are being formed. So this is a stellar nursery. But just look at that structure there. That you can see down below. There's like a big curve and the dust. So you've got the swirling gases all around, but it's really fascinating to look at the detail of that. And that's pretty good picture of that tonight. Let's see. Okay, so what's next on our list? M57. Well, we're bouncing all around. You know what? I'm going to go out of order because we have right below the eagle is M17. Don't remind me not to forget to go back to M57 when we're done, but let's just do this tour of the center of our galaxy here. I'm going to move down to M17. Oh, we didn't center that, did we? Did you hit center on that? Yeah. Oh, well, too late. So the telescope has moved, and we're just waiting for it to update. We're going to see another nebula come in here. I'll just let it superimpose itself. Be kind of an interesting picture. And can you center that up for me? Okay, M17, the Swan. Other people call it the Omega or the Horseshoe. Let's see if Christina can get this thing looking good. So Christina and our guests are looking at the monitor to get things centered up. While they align it, we're just kind of waiting for the camera to update. And, got all kinds of swirlies there. It's a good dark night, isn't it? You should be able to see the Milky Way out there quite well. I can't see anything with all these computer monitors in here, but it's just a dark abyss out there. So I'm sorry, I didn't get your first name.
Oh, Estevez.
Estevez?
Yes.
So this is the first time you've been to the observatory. Have you ever seen like the Milky Way and stuff like that before? I know you haven't.
No, I'm not.
And were you able to see it tonight?
Yeah. You showed me the way.
So we've had a lot of people. They live down in the valley or something. They've really never seen the Milky Way. They come up to the mountains here, and it's pretty nice.
Yeah, I'm not used to seeing this many stars.
Yeah. Well, the other thing about seeing this many stars is you probably don't go outside without lights on.
Yeah.
And if I turned on the fluorescent lights in here, we'd all be in pain. So our eyes are really dark adapted, and it takes about 20 minutes to get that way. Okay, have you moved it lately? Okay. There's some more, right? Okay. Oh, you're on slower now, aren't you? Okay. Okay. I don't know if your audio is coming through or not, but she's talking to me out there. I don't know if you guys can hear her at home or not. supposed to be able to hear her, but I don't think it's coming through. Again, we have a lot of swirling hydrogen in this area of the galaxy. It's kind of neat to see these outer line. You know, most people just focus in on the middle of it, but okay, can we? So this is upside down, if you want to call it the swan. So if you turn your head upside down, you can see that there's a swan swimming on a black lake. So I don't know if I can do that here or not. Let's see. How can I do? I don't know if I can rotate. There's a way to rotate this, and I don't know if I know how. I'll have to learn that. Horizontal flip. How do I do a vertical flip? No. Actually, Christina, can you hand me the camera control? It should reach over here, I think. I'm going to try something.
This?
The actual camera exposure controller, the little box.
Oh.
You're going to have to stretch the wire across, but Olin handed it to me one night because I didn't think it would reach, and he said, "Here, you do it." Okay. There's something I want to try here. See if I can. Okay. Yeah, it does reach.
Yeah, keep going.
Oops.
I didn't know there was a whole other menu.
Yes. All the secret menus, but why is it not letting me do it? You like got stuck. Great. I was trying to.
Communicating?
Yeah. Oh, there it goes. Oh, you know what? I think this menu may wait till it does another update. Is that? Can you get out of that menu? Is that the return right there?
Yeah, it is.
Okay.
Oh, can you not see that?
Yeah, it's behind the text. Okay. Let's go with that for right now. And I'm going to. Now down is up and up is down, so I want to go down just a little bit. Now let's let this. Now it's going to look like a swan. That's why I was doing that. Do you guys see the swan now? What's that?
Yep.
Yep. Okay. It was upside down before, so we just tell the camera to reverse it.
And like you said before, it looks like it's on a dark lake.
Right. I thought I moved it. There it goes. Well, this is going to confuse some docents when they watch the YouTube, and then they're going to say, well, it's backwards from what I saw. Although, if we do a meridian flip, it will flip it over too. So it depends on what time of the night you look at this thing.
Can hardly see from in here.
Yeah, from in here you can't see what's going on out there at all. But let's see if I go back to here. So we're looking at this from that side of the meridian. Yeah, that would be until later in the month, and then we'll flip over. Okay, I'm going to go with that. M17 is an emission nebula, and it's on an open star cluster also, and it's in the constellation Sagittarius. M17 is popularly known as the Omega, the Horseshoe, or the Swan, and is the brightest emission nebula in the northern hemisphere. It's second only to M42. Oh, wait a minute.
No, you're right.
Yeah, it's second only to M42 in Orion. But why did he say? If Forrest was here, I'd ask him. Let me read that again, because if it's the brightest, how can it be second only? Is the brightest emission nebula in the northern hemisphere.
So it's one of the brightest.
Second only to M42 in Orion. Okay, I think what the reasoning there is. Well, I was going to say that maybe it's southern. Orion's considered a southern constellation, but so is Sagittarius, I would think. I'd have to look at where the ecliptic is. Okay, we don't know everything here. I just know it's kind of pretty. So anyway, this has been another one of my favorites. This is an easy one to show people in even a 6-inch telescope. If you point it at the Swan, they can make that out quite easily. It's nice and bright.
Yeah.
Where some of these things, like the galaxies, you show it to them in a 6-inch telescope, and it's like, what am I looking at? Well, there's a fuzzy star there, you know. So, but this is always a crowd pleaser because you tell them the story about the Swan. You don't normally see the little swirly things behind the tail. So, when you're looking through a telescope visually, you don't get quite as much of the lightness as we have here. So, so anyway, M17, the Swan or the Omega. It's really cool. I guess while we're here, we should probably go to M8 since it's right down below. Well, really, we should go to M20 because it's on the way down. Objects, July. Well, we'll go to M8 next. Scope moving. And we'll just watch this update here while I change the graphics.
Do you want the restrooms? Thank you.
I'm going to go out there and readjust those menus on that camera to put this back to normal so it's not backwards for everybody. And we need to center that up a little bit. Okay, this is M8, the Lagoon Nebula. It's a little bit off to the left there, so let me move over to the right and down just a little bit. I might have something interesting for you guys. Let's see. Thank you. A lot of red in this picture, huh?
Oh, I almost thought we were still on.
I just went to M8, yeah. Let's see. That looks good on that 60-inch monitor in there.
Yeah.
Um,
Very clear.
pictures.
What?
So I'm gonna move this over a little more and down a little more. Well, while we're looking, I'm going to bring this. So we're waiting for this update. I'm going to show you another picture of it that I actually took while we're waiting. This is a little bit wider field of view. We're working on getting a higher resolution camera, so I'm curious how YouTube broadcast. This would be more in lines with what we would be able to do with the new camera that we're looking at getting. So could be interesting. We're waiting for that to update. So if you look, well, this is going to be a little bit reflected mirror image from here, and this is more magnified in the camera that we currently have. Again, you can see those knots and stuff like that where the protostars are, and a dust lane, dark dust lane that goes through the middle. Actually, can you turn the integration knob down just maybe a quarter of a turn? We'll darken this up just a little bit. And while you do that, I'm going to move over to the right a little bit more. Maybe down just a little bit. Of course, if you know about astrophotography, you'll notice there's a couple other things that are telling about this telescope, different telescope than the one we're using. It's actually a Newtonian reflector. You can tell it has there's a stars have 4 points on them, and that's from the spider vane that holds the secondary mirror. This is an image, not very good right at the moment, but this camera is mounted on an SCT telescope right on the corrector plate. So there is no spider vane holding it in place to diffract the stars, although there is a wire coming off of the camera, so we see a little spike going vertically. This just doesn't focus, does it? Do you want to try to focus that up a little bit? Do you dare? Adjusting the focus there on the telescope. What do you think? Have you seen an update yet?
No.
Not yet, huh? Well, we can talk about M8, I guess. M8 is a large 6th magnitude emission nebula in the constellation Sagittarius. It's popularly known as the Lagoon Nebula. It's one of the finest and brightest nebular regions in the sky. It is a giant cloud of interstellar matter that is currently undergoing active star formation. It has already given birth to a considerable group of young stars known as the open cluster NGC 6530. You see it there just a little bit to the right. It's embedded in the nebula there, as you can see. Look for the faint traces of color. Even in the 17-inch scope, you'll see a little bit of color on this one. But normally we kind of see it kind of greenish gray. Our eyes are much more sensitive to greens than they are grays. Now this nebula actually has reflection and emission in it. Tell you what, go ahead and get the camera controller out and let's go to white balance and play with it a little bit to see if we can pull out some of the reflection nebula. So yeah, go to white balance. And let's turn the red way down just for fun. See that? So you can see where the blue is reflecting, the stars are reflecting the blue. So you lose some of that nice aqua turquoise color with the overpowering hydrogen and red. So what we've done is we've kind of reduced down the red glow now, and we're looking more at the reflections. Go ahead and go back in there and let's bring the red up a little bit more. Let's see if we can get a nice balance between the two. So bring the red up 2 or 3 notches. And now bring the blue up a little bit farther, and let's see if we just accentuate the blue a little bit. Yeah, it's kind of making it. Nah, I like it better the other way. Come on down 2 notches, and bring the red down 1 more. Yeah, right there. Yeah, let's look at that for a minute. So we've kind of balanced the color out. It's not as vibrant, but you can see now where it's glowing red and where it's glowing blue more. And then the brown is, yeah, the dark area is a dust lane. Turn the knob counterclockwise about a half a turn. Let's just get this, see if we can get a little more contrast out of it. And we're using a video camera, so there's some compromises. And this same through a DSLR looks like this. That's an unmodified T3i. Did it update?
I thought I saw black.
Okay. Well, I'm going to take a look at, let me see here. Yeah. Alright, let's go ahead and go to another object. We'll go to M20 next. M20. Okay. Oh. Is it off to the left also? I guess I should have centered M8 after we finally got it over there, huh? Okay, we'll move that around a little bit. Here it comes. Right some more. Okay. 1, 2, 3, 4, 5. 1, 2. That'll be better. Center that up. Okay. So this is M20. Oh, we're missing the top part, aren't we? Down, 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 down. Okay, we're gonna wait for that one. This is me. So while we're waiting, I just playing around with the cameras here. We need to get some better stuff behind me here. Maybe a monitor or something. But so there we go. Now I've got that adjusted better. Okay, this is the Trifid Nebula, M20. M20 is the Trifid Nebula and an emission nebula in the constellation Sagittarius. It's famous for its characteristic visual three-lobed appearance. Dark gas and dust clouds are in the foreground that block light to produce the tri-lobed character of the bright nebula. However, clarity shows 4 distinct components. Look for that faint blue reflection nebula component. So you can see up toward the top there's the blue, and then down below there's the red. So there's more of a reflection nebula around that star toward the top, and then more of a emission nebula around the lower part, and then there's the dark dust lanes that segment it up. This has always been a cool one. You can also see You also see some of those pillars, like in the Eagle Nebula, just down at the bottom there too. Let's play with the white balance on this a little bit. So you want to go ahead and let's put the white balance back to the center on both red and blue, just to see where that goes. We'll have Christina adjust that for us. Okay, so you can see how this sky around it is kind of red, and I'm not sure. Let me turn off my light in here. I don't know if that's still. We're still pretty low out toward the wall, aren't we? So with those two knobs centered up, that's neutral white balance. But since the sky looks kind of red here, I would say let's turn the red down just a little bit. So you get a gray. There you go. It's a little bit more natural. Let's turn the blue up just for fun. Let's see if we can get that reflection to show up. Yeah. It makes the sky artificially blue though. But there's a little blue in the. Okay, that kind of shows there was some blue by that star in the middle there too. And now that you turn it down, I notice it more than I did before. So if you put blue back toward the center, maybe up one. What do you think? About there? Yeah, let's leave it there for now. The Trifid Nebula. I'm going to go through that again, just so we have this. So this is M20, the Trifid Nebula. It's an emission nebula in the constellation Sagittarius. It's famous for its characteristic visual three-lobed appearance. When you look through a telescope visually, you see basically the three lobes. In the video, you can see four. There's dark gas and dust clouds in the foreground that block light that make a character in front of the bright nebula. In the video, we can see that there's actually a smaller little dust lane there. Just the camera is more sensitive than our eye, obviously. And then when you're looking at this, always look above, and there's that faint blue, which is the reflection nebula around that other star. So the Trifid Nebula, always a big favorite. So now we need to go back to M57 we skipped, right?
Yes. And then we need to go to Pluto.
Well, then we got M27 too. Okay, so M57. While we wait for the telescope to settle down, we'll watch you out. Working hard with all these computerized scopes, huh? Let's see. There it is. If you could center that up for me. M57. Okay, Christina's working on getting that centered up. We still have a little bit of remains of the Trifid and the ring, and nice looking ring tonight. Now let's see if you can get it up toward the middle of the picture. Make a pretty picture out of it. There you go. You need three of them there. All right, so let's see here.
Me in the middle.
All right, I guess that's good enough. Is it going to move on me again, or is it? That's it? Okay. Great. So M57, the Ring Nebula, in the constellation Lyra, is probably the most famous planetary nebula in the sky. The image of M57 on the video monitor is an excellent example of how suns such as ours end their lives. Not with a bang, but with a series of one or more soft puffs. Contrary to recently abandoned theories, the ring is not the outer surface of a spherical shell, nor is it donut-shaped, but it is now thought to be tubular shell from the parent star. We are looking almost directly down from the top. Compare this image to that of the tubular structures of M27 and NGC 6302, which we see from more of an oblique angle. We'll go look at M27 in just a second here. So the planetary nebula are not the result of an exploding star. The star bloats out, runs out of fuel, and it starts to get bigger and bigger and expands, like in the case of our sun, probably out toward the diameter of the orbit of Jupiter. It becomes a super giant star, and then it can't hold the gases anymore, and it just kind of sloughs them off on the outer, and then it collapses back down. So as those outer layers of gas ever expandingly go outward, when it collapses down, you'll have a white dwarf that could be only hundreds of miles in diameter. And if you look really closely in the middle of this ring, you'll see there's a little white dot. It looks kind of greenish to me here, but that's what's illuminating those clouds of gas. So that's M57, the Ring Nebula, a planetary nebula. Not that it has planets, but it kind of looked like a planet to the early observers. So next on our list is the last thing on this page is M27. So we'll go to M27. Scope didn't move. I'm sorry, what? You know what? Oh, I didn't see it, or did it actually move though? You heard it move?
I don't think I've heard it move.
Okay. Did you move it a little bit with the?
Maybe it doesn't have to move.
Maybe I programmed M57's coordinates into M27. Huh. Okay, time for the iPad. Let's see. We'll go to search. July's list. M27. Scope moving. That's more like it. M27, the ring nebula, so this would be the D-E-L-L. That kind of gives you a good idea of the difference in size of these two, huh? So this is the Dumbbell Nebula.
Or the apple core.
Apple core. What's the other thing I've heard it be called? Again, this is from a star that has ended its life in a less than spectacular way, but it makes a spectacular image. So the Dumbbell Nebula is in the constellation Vulpicula, and it competes with M57 for the most popular planetary nebula. You see this one a lot too, although I see the Helix a lot also. Having undergone a stellar collapse around 48,000 years ago, the blue-white dwarf star expelled two gaseous cylindrical shells. One shell of doubly ionized oxygen is expanding at a velocity of 9 miles per second, while the second shell of ionized nitrogen is moving outward at 20 miles per second. So they're going at different speeds. So is that why is that a red shock wave maybe? I don't know. So, there are other things on our July list, but we're not going to do those right now because they're actually better observed in the 4-inch telescope. Things like the Wild Duck cluster. We'll just see a couple of stars. A carbon star, actually, we could show you that real quick. But so we're gonna go ahead and go to Pluto and then sign off. So let's see if we can go to Pluto. We'll go to search. Let's see, planets, Pluto. Which side of the meridian is the scope on? If we do a meridian flip, we're going to have to go somewhere else and then go to Pluto. Scope moving. So we'll go ahead and so that stayed on the same side? Good. Let's see here. Okay, so Pluto is right there in the middle somewhere. Which one is it? Maybe if we save this picture and come back tomorrow night and take another one, we can find out which dot moved. So that's pretty much how you have to observe Pluto, is by watching it night after night and seeing that it's moved, and you'll see that you combine the pictures and you can see that it changes. But that's pointed over at Pluto. Now, And of course, if you've been watching the pictures that are coming of Pluto, you probably have seen that it's got well, it has like a big heart on it. So let me see if I can pull something up for you. Uh-oh. How come it moved? Did you bump the scope?
Nope, didn't even touch it.
Huh. That's weird. Well, there's an image of Pluto from the New Horizons probe, and it's got a heart. Although my daughter said she saw something of that where they drew Goofy. Oh, I see the Goofy. His nose is on the bottom left. His eyeball is just to there. Yeah, not Goofy. I'm sorry, Pluto. Somebody had overlaid Pluto, and they're saying that this area here is his nose, his eye, his head. So yeah. So anyway, but that's where did the scope go? Huh. Oh, let's just didn't do that right. We'll get this with the title up there. So there's Pluto. And I just want to recenter that just in case. Go to. Yeah, it's there. Okay, so this is where our telescope says Pluto is. Right in the middle there. But it's one of the really, really faint ones. It's one of the faintest ones you can see in there. So that's it. If you want to go out there, I will have you put the telescopes, park them, and so this is Christina Adams. She's putting our scopes away tonight, and one of our newest lead docents here at the observatory. Okay. So she'll park these telescopes, cover them up, and get them put away. And we hope to see you down here in person some night. The observatory is located on Green Valley Road in Placerville, just behind the Folsom Lake College. And we're open every Friday, Saturday, and Sunday night. Summertime hours, 8:30 to 10:30. If you're watching this in the wintertime, our hours are 7:30 to 9:30. So that's about it for tonight. Did we miss anything? So that'll do it for tonight from the observatory. I appreciate you guys checking in with us, and hopefully you enjoyed watching what we do here. And come on out and see the stuff in person.